Hello everyone, welcome to Coder and Boots. So in this video, we are going to discuss about what is multi-stage Docker build. Okay, so this is a very important and a powerful feature within Docker, and this is very important while using Docker in production applications. Okay, so Docker multi-stage build is basically in a Docker build we will use multiple stages. Okay, so when we start learning Docker, we'll be using very simple Docker files where we'll have a single from. Okay, so if you analyze the structure of a Docker file, we will have a single from statement, and then for example like this, a single from statement, and we'll have multiple other commands, or various stages or steps, not stages, various steps to perform on top of the base image. Okay, from defines what is the base image, and on top of the base image we are specifying what's the work directory, copy something, right, run this, right, and finally entry point like this. So but this is the case of a very simple Docker file, right? But when it comes to complex application, there can be so many steps, internally, and also the size of the image may increase. Okay, and finally we'll end up bundling a lot of things. But this multi-stage Docker build is something that helps us to simplify and optimize our Docker build and the image creation process. So as we say, there will be multiple stages in the Docker file. Okay, so that means there will be multiple from statements. Okay, and each stage can be it can start with a new fresh base image, or it can use image from one of the previous stages. Okay, so the beauty is the final build. Okay, so once we do Docker build command, right, so it will execute all these stages, and the final image will have only the image from the last stage. Okay, so whatever is there or whatever is processed from the last stage, right, that is what gets bundled in the final image that gets built from this process. So that means the intermediate processes or the intermediate steps that we have in the entire Docker file, those things will get executed, and whatever is required from all those stages we can take it, and whatever is not required we can omit it. Okay, so in this way we will get a final clean image with the required items. So in the original case, without using the multi-stage, what happens? So we end up bundling so many things, and finally we'll have large image, right? So I've seen Docker images of 15 GB, 20 GB size, and this is it's a very big problem in case of production deployments. So let's say you are working in an offline environment, you will end up bundling and transferring terabytes of Docker images to the target environment. And also in case of deployment also, it takes a lot of time because this need to get transferred over the network, right? So let's say if you're pulling from a repository, so 15-20 GB for each image need to get pulled from the repository, right? And also in case of Kubernetes and all, the let's say if the deployment, if the pod moves across nodes, what happens is all these images need to get cached in all the nodes. It will take up so much of space, it will take up so much of network bandwidth. All these are complex problems that we encounter. So the solution is we need to reduce the size of the image. Okay, and with this multi-stage Docker build, so this gives us a solution to this is one of the solutions to reduce the size of the Docker image. Okay, and also as the size is less, that means less contents inside the final image, so that gives one more advantage. Okay, so that means very less luggage, so that means less chances of vulnerability, because the attack surface, right, on the final image will be very less, because it's a, let's say, instead of having a 300 MB or maybe 2 GB of image with a lot of things, if we have something like a 300 MB image which has very minimal things and the very minimal requirements or dependencies, right, then the possibility for an attacker or the options for an attacker to attack inside that image, right, it is going to be less. Okay, so it will improve the security of the final production image as well. Okay, so as you can see in this diagram or image, you see if you are carrying a lot of things, right, it will be very difficult, right? So but if you are carrying only the required items, so that means less luggage, more comfort. So that is the advantage of this one. Okay, so I'll explain you how this like multi-stage build happens. So as I explained, there will be multiple from. So this whatever you are seeing on the screen, this is a single Docker file. Okay, and compared to a normal Docker file, you can see that there are two stages. There are two from statements. So one is here from Golang 1.20 as builder. Okay, so that means the first stage we can give a name. Okay, so as builder, so as means I mean we are giving a name to the first stage. So this is like I mean the builder, and then we specify like work directory app. Okay, copy, do something, run. Okay, so in this one what we are doing, we are building. Okay, we are building the Go program. Okay, and finally we are getting the build. Okay, so then what we are doing, once we do the build, once we do the build process, then to run this application we don't really need Go, right? So for building this we need Golang, but that's why you see the base image is Golang in the builder stage. So we did that and we created the build. So the my app, so we have a my app, that's a final build, and for running this final build we don't really need this Golang. That's why we have a stage 2. Okay, it's all in the same Docker file. Stage 2 we used a lightweight Alpine image. Okay, so this is a lightweight Alpine image, and there what we are doing, we are specifying work directory and we're telling copy from. Okay, from we are specifying the previous stage. Okay, so there are options. I mean, if you are not giving a name to this particular stage, what will happen is the stages will be numbered. Okay, or I mean given it's like I mean index, right? 0 1 2 3. The first stage will be numbered with 0, second stage will be 1, third stage will be 2, like that. I mean there will be number. So if we have a name associated or alias associated with the stage, we can use that stage name. Otherwise we can just use the number. Okay, copy from equal to 0, that means it will pick up from the first stage. And what we are copying, we are copying /app/myapp. Okay, so our build, okay, actual build is what we get, what we copy from there. Copy and keep it to the second image, and then we run this. That means the final build, okay, the final build after building this entire thing, the final image will be only the stage 2's output. Okay, so stage 2's output will be less in size, lightweight in size compared to the stage 1. Instead of using Golang image, the Alpine image plus the build will be light. That's the advantage. Okay, so this is a simple example, but depending upon your use case, you can have n number of stages, you can have complex steps. And another thing, like I mean, instead of referring, so this copy from, it accepts previous stages, or it even accepts external image. Okay, let's say if you, instead of builder you want to use let's say an external image like Nginx, Ubuntu, or whatever available in the Docker registry or your custom registry, you can specify that image and the tag. Okay, so it can even copy from that is just an explanation, just for explaining it, that's why I'm telling. So it can even copy from an external image as well. Okay, so in this way it takes care of all your needs. So then the benefits of multi-stage builds. Okay, so as I explained, the benefit of multi-stage is one is reduced image size. Okay, the overall size of the image is very less. What's the reason? Because we are only copying the required artifacts. Okay, so we are doing all the build, compile, whatever it is we are doing in the previous stages, and the final image we will only use the final version and the required artifacts. Okay, we will not carry all the things that we used for building or build toolkits and all. We will not be using that. We will only use the build. Okay, so that means the final image will be of reduced size. Improved security. So because the final image does not have the build tools dependencies or anything, right? It will be light in size and it will be very minimal. So that's why the attack surface will be very less, and that improves the security. Okay, so simplified CI/CD pipeline. So this entire, if you see this the previous Docker image itself, so if you have to automate this thing in a different process, right, in a normal CI/CD process, you will have to store the intermediate image somewhere, right? You will have to push it somewhere, you will have to pull it some again, right? You will have to copy that. So those are all complex things, right? But as we can embed everything in a single Docker file, so this simplifies the CI/CD process as well. Right, then you don't, if you are using GitHub, GitLab, so you don't really need to do complex like pipelines or create complex stages in your pipeline definition, you can embed everything in the Docker file itself. This reduces the complexities in the CI/CD pipelines. Okay, so these are the benefits. So I'll be explaining different scenarios of this multi-stage builds in separate videos, but in this video I'll cover the basic overview and some examples. Okay, so the key concepts, okay, it's a very simple thing. So if you know how to create a Docker image, okay, so if you know how to read and create Docker files, you will be able to do this very easily. It doesn't take a lot of time. So first thing you need to understand is, as I explained, this in this Docker file we can have multiple stages, like stage 1, stage 2, stage 3. You can have any number of stages, and as I explained, every stage will start with a from an image, right? So this from, we can give a name to each of these stage, or we can leave without a name. Okay, so that means if here in this scenario on the left hand side, whatever you see here, I have given what I have given from the base image of Golang. Okay, I am doing something, right? I am building it, right? Work directory, copying the code, then doing the build process, but I have not given any name to this particular stage, right? So in that scenario, if I have to refer the stage 1, I'll have to use like the 0. So as I explained, stage 1 will be 0, stage 2 will be 1, stage 3 will be 2, stage 4 will be 3, like that. You will have to use the integers starting from 0, 1, 2, 3, 4, 5 numbers. Okay, it will go in the numeric order. But let's say if in case you are giving a name, so on the other side you can give a name as well. You can give using as, you can give a name. So that means from Golang 1.19 as builder. Okay, so that means the stage 1 will have a name builder. Then we can do whatever it is, and then you can refer the previous stage using the name of the stage. Okay, so here in this case, second stage I didn't give any name. Let's say we have a third stage, I'm giving maybe some name to the second stage as stage 2, and then third stage I can use copy from stage 2, from equal to stage 2. Here I have used, as we have a name, I have used builder. Okay, so you can give any name of your choice. Okay, so that means the idea is we can give. So it's always better to give name to the build stages. Okay, if you don't use name, then if you have like a very large Docker file with a lot of stages, it will be difficult to from a readability point, from a maintainability point, it will be difficult. Okay, so then second key point you need to understand is, if you have a lot of stages in a Docker file, okay, so this multi-stage build, there is a capability to stop. When we are doing the build process, we can stop at a specific stage. Okay, let's say if we have 5 stages, and maybe as part of my process, I don't really need to execute all 5, I just need to execute till stage 2. So then we can do what? Docker build, we can specify an argument target. Okay, target build, okay, -t stage 2. Okay, so I can basically give okay, so I can basically give a target. It's not like, I think I did a mistake, stage 2. Okay, and -t, I allow to give the image name. Okay, build with stage 2 dot. Okay, so I just did a mistake, because here I have to use -- target stage 2. Stage 2 is the name of the second stage. Okay, and -t, this is a tag. Okay, build with stage 2. So Docker build, we have to use an argument -- target stage 2. Okay, so you can give whatever is the target stage. Till that stage it will run, and then it won't process the remaining stages. Okay, so this is an important thing. And one more thing you need to understand is, there are, like, if you see the latest versions of Docker engine, so it comes with build kit. Okay, but with the older versions of Docker, it comes with the legacy builder. So in case of legacy builder, what will happen is, if you specify target equal to some stage, right, it will execute all the stages till that one, irrespective of whether it is dependent or not. Okay, let's say if you are running a Docker build and you have let's say 5 stages. Okay, so, and let's say you're not specifying the target at all. If the stages are not dependent, what will happen? In case of legacy builder, it will execute all the stages. Okay, but in case of the Docker engine with build kit, what will happen? If there are no dependencies between the stages, it will not execute like the intermediate stages. So it will execute only the dependent stages till the final stage. Okay, so that you have to be careful with that. So because the latest engines will be with build kit. Okay, so I'll explain this how to handle, because if you want to execute, let's say you, as per the process, if you don't have dependency between two stages, right, what you can do is you can just share a file between, just create like an empty file or maybe just a text file that shows like the previous stage is complete or something, and share it with the next stage, so that it will internally, technically it will have a dependency, and so that the previous stage gets executed. Okay, and there is also a way to disable build kit. Okay, by passing like an argument, you can specify the build kit based execution, so that it will follow the legacy builder execution. So I won't I'm not going to get into this part. So but as we are just starting with this multi-stage build, right, I'll explain the basics. Okay, I'll cover more advanced sessions related to this in the upcoming videos. Okay, so understand, we can stop at a specific stage. Then next, I have already explained it. So we can refer external images in stages. Okay, so previously we have seen like copy from a stage name, right? So but in this case, if you see, we are copying from what? We are copying from some image, nginx latest. It is not a previous stage, it is basically an external image. This image might be there in the Docker repository, the Docker hub or somewhere. Okay, so in that case, what will happen? It will pull the image, it will do, it will copy this /etc nginx conf from this image and copy it to nginx conf locally, right? So in this that means we can refer to external Docker images also. It's not just the previous stages, we can refer to external Docker images also in the stages. Okay, then we can use another thing, as I explained at the beginning, we can use a stage as another stage. Okay, so let's say if you see here, from Golang, this is the stage 1, from Golang as builder, this is the first stage, and second stage what I did, I used from builder as builder 1. Okay, second stage I named as builder 1, but from where it is taking? It is taking the previous stage, right? So this stage, whatever is this, it will use the entire stage in the second stage, it will do the work on top of that. Then third stage, what I am doing, I am referring again builder from builder as builder 2. So whatever is there in the first stage, right, the entire stage will be used here and the work will happen on top of that. So depending upon your use case, you can use a fresh image in each stage, or even you can use a previous stage as another stage. Okay, so just for your understanding, so that you can define and design your solutions. Okay, so these are the key concepts. So like basically name, okay, name your stages, stop at a specific stage if required, then use external images, then basically difference between legacy builder and the build kit, and use previous stage as another stage. Okay, these are the key concepts. Now what I'll do is I'll show you some example. Okay, so this is a simple Python, it's a simple Docker file with Python inside. Okay, so if you see what happens, we are doing, so this is a typical scenario that developers use. We basically use the base image, like this is 3.1 to full version Python. Okay, this will be of a significant size, it is not the lightweight Python image. Then we have created the work directory, copy the test cases, copy the source code, then requirements.txt and the text execution script, right? app.py, this is the main entry point of the app, this is basically for running the test cases, this is the dependency. Just assume. Okay, then we are just doing the pip install of all the requirements. Okay, and then what we are doing, once the entire installation dependencies, all those things are complete, we are doing the test script execution. Okay, so that means test script will execute. We are bundling what? The test related code, okay, test scripts, and the test trigger command line, and their test execution will happen. The results also will come. Post that, once it is success, we are saying okay, run it. Okay, and this entire thing will get bundled in a single image itself. So what will the problem will be, we end up using like the full sized Python code, and also we end up bundling all these unwanted things. Unwanted things means we don't really need this test script. Okay, we don't really need the requirements required for the test scripts. We don't need this test.sh, script.sh, right? Okay, and the results of this also, that is also not required, right? We can simplify this. So that's why if you simplify that, we can make it in something like this. Okay, so we can create a base layer. Okay, we can have a build layer, right? Then we can have a test layer. Okay, and then we can have a prod layer. So if you see, this is stage 1, stage 2, stage 3, stage 4, right? And in the final prod, if you see what we are doing, we are just using, what is the base? Base is the 3.12 slim. This is a very lightweight base image, right? And on top of that, what we are doing, we are just taking, we are copying only the we only have what the final app to be executed, right? So it's technically there are some stages missing in this, so I just created it for a pseudocode kind of thing. So but take it in that way only. So because if you see the app.py, I didn't copy in the base image, but take it in that way only. Okay, so but in this case the entire process is segregated into small pieces, and in that, okay, yeah, it's there. Sorry, I think yeah. So in this way, this is it's not basically 4 stages, it is 3 stages only, 1, 2 and 3. Okay, so we are copying the source, requirements.txt, app.py, pip install, then the test layer and the final prod layer, right? So in this way, the final base image will be few MBs of size because it will be very lightweight. And as I explained, if you see here, run echo test successful, right? So why I am using this linkages and I am referring it here is, in case of the Docker with Docker engine with build kit enabled, right? So if I don't keep this dependency, so if you see line number 15 and line number 19, this creates a link between. What we are copying here is just a sample or a simple empty text file which has only test stage successful, but it is internally creating a dependency between this prod layer and the test layer. Okay, so if you don't have this, if you comment this, what will happen? There is no dependency between test layer and the prod layer. So if you are running with the Docker engine with build kit, it will execute the first one and the last one. The second stage will not get executed. Okay, so just to avoid that, we are keeping this kind of dependency. But if you are running it with the Docker with the legacy engine, what will happen? The legacy builder, so it will execute all the stages. So now I'll show you a practical example. So this is something that like as a Python developer you may encounter in your day-to-day activities. You might have seen images of several GBs of size. Okay, that usually happens. The size of the image, even if you start with a slim or a simple Python, so it grows beyond that because of the installation of the Linux dependencies or the C library dependencies. Okay, so for example, if you are using PyODBC, okay, or if you are using some Postgres database connectivity library like this PSY copyg. Okay, so if you use this Postgres package or PyODBC or some other things, it needs Unix ODBC. Okay, and then the Linux C toolchain. Okay, the C toolchain and the build essentials, the entire packages, the Linux dependencies you need. And this package itself, if you do this apt-get install, this itself will increase the image size by approximately 300 MB easily. Okay, but this is not required at the final runtime. Okay, this is only required for the initial installation. So final run can be for executing or for using the package. We don't really need this entire libpgdeb or build essential. Okay, so for final run, what we need, we just need the simple Linux package libpg pg5, right? PostgreSQL 5, right? So and this one, with this, if you are avoiding this, we can easily save around approximately 300 MB size. Okay, and in the initial build part, I am using Python 3.12. This image size is coming somewhere around 300 MB, or it's not even 300 MB, it's more than that. Okay, it's near to a GB, I think. And the slim version, it's less than 100 MB. Okay, so this is a lighter version of Python. So the slim version, I'll use it in the prod stage. If you see this from 25 onwards, this is the prod stage, and till 25, this is the build stage. Okay, in the build stage, what we use like the full size to Python. As we are maintaining the same version of Python, the directory structure, folders, everything will be the same within the image. Okay, the only thing is this will have some lot of libraries. This will have come with less libraries. So even if you do copy, or even if you copy virtual environments between these two images or stages, it won't create any problem, because the path, because see, technically virtual environments we can copy from one environment to another environment, but the challenge is if you are copying manually in machines, in Linux machines, what happens is the path, the linkages and all may break. Okay, but in case of Docker images, if you are using the same version of Python, even if it's a slim and the the higher version, right, the directory structure will be mostly the same except for some packages and other libraries. So you can easily copy this virtual environment without any challenge. Okay, that is what we are doing here. If you see, we have the builder images 312, the prod images 312 slim. Then what we are doing, we have the build stage. Okay, we named it as build, and then we are installing the C toolchain and the C build time dependencies. Then what we are doing, we are creating a virtual environment, right? We are adding the virtual environment to the path. Okay, then what we are doing, we are setting the work directory, copying the requirements.txt, installing the requirements.txt. This requirements.txt will have what we have Flask, and consider a case where we have a Flask web service with Postgres database connectivity. So we need the Postgres package as well. So we have these two packages. That's why it installs all the requirements.txt, everything. Okay, the first stage will have this much. Now in the second stage, that's a prod stage, what we need, we just need the packages, installed packages and the code, right? So for that, what we are doing, we are installing only the libpg5, right? So this lightweight package we will install. Then we are copying the virtual environment, whatever we have installed in the previous stage. Okay, so because once we have the virtual environment, what will happen, the installed packages will be available in this, required for the program will be available in this. So that environment we are copying from the previous stage to the current stage. Okay, adding it to the path. Then what we are doing, we are copying the app.py and the required configuration. If you have configurations, everything, right, it gets copied using this copy. Finally, we are doing app.py, or we can even do what, we can even do Python app.py. Okay, so we can use this. Okay, in this way, the final image will be only this much, and this may be like in a few MBs. But if you do in this way, this image size will be of maybe the double the size or even more than that. Okay, I'll show it in practice. So as I explained, if you see this location, we have app.py is there, Docker file is there, Docker file.1, it's a copy of this with a small change to show two scenarios. Then requirements.txt. Requirements.txt, if you see, we have Flask and the copy. And Docker file, let's examine the Docker file. This Docker file, if you see, it's the same thing, 3.12, 3.12 slim. We have these two things over here, and Python 3, all these. Okay, so we have a simple Flask application, and the final app.py we are copying, Python app.py. Let's understand what is there in the app.py as well. It's a simple program. So what we have is we have import Flask. Okay, doing this. I'm not using the Postgres package in this one, because assume like we have a Postgres database connectivity inside this program. That's why I'm using the Postgres in the requirements.txt. Okay, now what I'm going to do is I'm going to build this. Okay, let's analyze the images that we already have in this machine. So Docker images, I already have some other images. What I'll do is I'll create a multi-stage app v3. Okay, so or let's give a different name, Docker build -t. Okay, web app multi-stage stage colon v1. Okay, dot. Let's run this. So it will take some time because okay, it created. Now Docker images, if you see web app multi-stage v1, it is 170 MB, right? Now what we are going to do is, let's try this Docker file. Okay, so let's cp docker file 2. So let's modify this Docker file, and instead of the prod image, let's try what happens if you use the build image. That's the full, basically the full 3.12 image. And also what happens if we install the build essential and the libdev. Okay, instead of just the libpq, let's see what happens if we install this guy. Okay, whatever we install in the build stage, right? Let's see what happens. So okay, so now we are going to create a v2 out of it. Okay, docker build -d web app multistage v2. Okay, so it is building it, it's creating the layers. Now docker images. Now if you see the web app multistage, okay, v2, okay, so the v1 web app multistage v1, it is only 1.170 MB, but the web app multistage v2, it is 1.6 GB. Okay, almost 10 times the size of our the previous image. Okay, so now you might have understood the benefit of having this multi-stage. Okay, so in this example we have reduced our image size by almost 1/10th. Okay, so it's not always the case, it depends on your use case, your scenario, but in this way, like, I mean, there is a possibility of reducing the image size. Okay, so you can try this multi-stage in your applications as well. So because reducing the size is one of the Docker image size is one of the challenge that you see in almost all the production environments. Okay, so it needs time because you need to analyze these dependencies, you need to understand the as an engineer, you need to understand the dependence required in the prod, you need to make it lightweight, you need to basically do an engineering inside the Docker file to make the final the production image lightweight and optimized. Okay, I hope this example is useful. So if you have any comments, questions, feedbacks, feel free to comment below this video. I'll definitely respond back. Thank you very much for watching this video. Have a nice day, and also subscribe to this channel for more interesting videos like this. If you like it, please like as well. Thank you very much.